Today we will see applications of discrete mathematics. So what is discrete structure? So discrete mathematics is a branch of mathematics dealing with objects that assume only discrete values, okay, or separated values. So we will see the example of discrete versus continuous. So the discrete data, the number of boys in the class, number of candles in the pocket, number of suitcase yeah, in airline. Okay. Examples of continuous data are height of person, the time in race, and the distance traveled by a car. Okay, so from this you will come to know the discrete. What is the discrete values? Okay. So how the discrete mathematical is useful in computers. So computers run software and stores the files, and these files are stored as a binary values 1 and 0. So these values are a discrete values, and all the computer data represent using binary. So is grouped into a bytes, you know that, okay, how the data is stored. So again the discrete mathematics comes over here in the storage of computers. Then discrete mathematics in railway planning. Okay, so in railway planning, how to expand the rail lines, okay, the train timetables, scheduling, and equipment for train trips. So both can be represented using a graph theory, and will be computed using linear algebra. Okay. Then discrete mathematics in computer graphics is such that using a linear algebra, which is used for transforming, scaling, moving the objects, that true for both applications like game development and operating system. Then discrete mathematics in cryptography, that is in computer network cryptography, is a method of storing the and transmitting the data in particular form, so that only those for whom it is intended can read and process it. So cryptography is important in maintaining the security, and also the passwords are stored in encrypted formats. Okay, so here the discrete mathematics plays an important role, and this is a famous, what we can say, protocol for transferring the data in military operations. Okay, that is in the encoded form. Then discrete mathematics, you know that in day-to-day life you might have gone through this Google Maps, okay, and we are finding the shortest route using the Google Maps. So again here the discrete mathematics for finding the shortest route, and the shortest route algorithms will be used for finding the route, okay, depending upon the user preferences. Then in image processing, the digital image processing uses a discrete mathematics for transforming the image from one form to other form, enhancing the image, and we are working on the image which is having a discrete data. Then networks, computer networks are the base of at the base of discrete structures. The routes that run on the internet are connected by long cables. Similarly, these networks we can represent like social networks. Okay, then Facebook network. Okay, so we are following on the Twitter, we are friending on Facebook. Okay, so these are all networks which we can represent using a graph theory. And another example you may take in a day-to-day life is the road structure, okay, which is similar to a graph structure. So national highway systems connected with the roads, that we can represent as a graph. Okay, and many more applications are based on this. Then voting system, there are different methods of voting. Okay, not like just cast and ballot. Okay, so here the possible voting methods can be studied, and how the outcomes are reflected by the intent of the voters can be studied using discrete mathematics. Then designing a password criteria, we know that the permutation and combination. So always you might have a email account, and it is always suggested that the password should be at least of 8 characters, and again it should contain the capital letter, numeric and special characters, so that the combinations will be much more, and it will not be easily hacked or cracked by the computer algorithm. Then discrete mathematics in logistics, that is flowing of information, goods and services, that can be managed using discrete mathematics. Then computer algorithms, that is algorithm is a rule by which a computer operates, and these rules are created through the laws of discrete mathematics. So for designing a efficient algorithm, the discrete mathematics is used, and the number of steps needed for completing the task, then speed of the algorithm can be um, what we can say computed with this discrete mathematics. Okay, then in relational databases, we know that the relational databases where the data is connected or have a relation between the two data, that is employees, for tracking the employees, um, the resources, client resources are managed, and the relational database connects the certain piece of information. For example, client information, the relational aspect of database allows the computer system to know how to link the client names, address, phone number and other pertinent information about the client. Okay, so all this information represented in the relational data can be worked with the set theory. Okay, then web searches, you have familiar with the web searches, and the multiple languages at once, and these are returning a summary, uh, which uses a linear algebra for matching and giving the what we can say relevant searches to the given query. Then scheduling problems, many more scheduling problems can be solved using discrete mathematics. That is the deciding the time slot for committee meetings, which chemicals can be stored in the part of warehouse, then deciding which nurse should work which shift, okay, which airline pilot should be flying which route. Okay, so all the scheduling algorithms can be solved using discrete mathematics, and always you can optimize the data using the algorithms. Then cell phone communication, efficient use of broadcast spectrum for mobile phones uses a linear algebra and information theory, and assigning frequency so that there will be no interference between the nearby phones is used or is solved using a graph theory. Okay, and again it is a discrete optimization problem. Then archaeology, it uses discrete mathematics to construct the 3D images from the scanned images. Okay, and the engineers uses lasers to scan many ancient structures to create a three-dimensional images. It uses a vector analysis and linear algebra to convert the billion measurements from the laser beams into coordinates, and then align the reading from the repeated to achieve the image that accurately within the millimeter. Okay, so this is very helpful to study the historical models. Then modeling a traffic, we know that the day-to-day life, the traffic is a major issue, and with the network traffic flow, we can manage this traffic, and we can predict the traffic patterns even. Okay. Then in power grid sector, the graph theory is used to finding the most vulnerable aspect of electric grids, and is used in power grid simulations. Uh, then data mining, here the data mining is the process of perceiving required information from huge data, and with the help of various methods, this data can be, or we are finding the useful patterns from this data, and we can represent that in the form of graphs. Okay. um, and many patterns can be what we can say, um, drawn from that data, which are useful for decision making in the data science. Then web designing, website designing can be modeled as a graph. So many more applications we can represent using a discrete structures, and these discrete structures are nothing but trees, graphs, and with that we can solve that particular problem. So here the web graph or web site can be represented as a graph, and that can be called as a web graph, and hyperlinks are nothing but the links between these two pages or number of pages, and we can have a optimum design for the website. In research, um, many applications are there which uses a discrete mathematics. So design of radar, sonar system uses a graph theory. Then robot arms are types of linkages under study, which uses a discrete geometry. Then power grid, we have seen that in the electrical power grids. Then train trips that can be scheduled using discrete mathematics, and graph theory is also used in cyber security to find out, identify the hacked or criminal servers for network security purpose. Graph theory is also used in neuroscience to study brain network organization. So these are the some useful resources where you can find many more applications of a discrete mathematics.